Remember how I told you it'd be really awesome if every equation you were given was in factored form already? Well, here's an example of why. This says find the zeros of y, find the zeros of y of the equation y equals x minus 2 times x plus 1 times x plus 3, then graph the function. Well, if you recall back in chapter 5, when we needed to solve an equation by factoring, we took the factors that we were given, set them equal to 0, and those were our solutions. But we also know that those solutions are our zeros or our x-intercepts. They're all kind of the same thing. So to find our zeros here, we take each of our factors, set them equal to 0, and solve for x. So here x is 2, here x is negative 1, here x is negative 3. Now we can plot those over here. So we have an x-intercept, I'll do the first one in black here, of 2, right here's 2. Negative 1 is here, I'll do that one in red. And then we'll do negative 3 in green. Okay, so there's my zeros. So now you might say, all right, how can I graph the function? I just have my zeros. And your question is valid, but taking information we learned from lesson 1 and lesson 2, or lesson 1.5, I should say, we know the end behavior, right? There's no negative coefficient, so it's a positive graph. And we should know from this lesson that if I have an x times an x times an x, we're going to have an x cubed. So that's a cubic function. So we know that they start and end opposite, right? Like this or like this. So because this is positive, it's going to end up, and because it's odd, they start and end the same. So this is going to start down here. Now, more specifically, I don't know exactly where it's going to turn. So that's not what I'm going to focus on. I'm just going to focus on where you're starting your graph. So we're now going to start it down here. And then it's going to turn somewhere up here. Again, if you make your turn up here, if you make your turn up here, no harm in that. We don't really know how high our relative maximum is. Okay, and then we go down here. Again, I don't know exactly where my turn is going to be here. It might actually be way down there, or it might even be off the screen. I don't know without graphing it, but you don't have to graph these in your graphing calculator. Okay, so there's the graph of our function. And if you type this exactly as it is in your graphing calculator, you should get something that looks similar to that. Like I said, the relative max and the relative min might be a little off, but it should start and end the same and have the exact same zeros. So let's look here at example 6. Find the zeros of y equals x minus 7, x minus 5 times x minus 3, then graph the function. So do the same thing, set each of your factors equal to 0 and find your zeros. Okay, graph your zeros and then use everything we learned about end behavior. We know it's going to be a cubic function, so you know they have to be opposites, and it's going to be a positive cubic function, so we know it has to start or end up here, and it's going to start here. So make sure you make that graph how you would need to using our previous lesson information. Again, I will check that tomorrow.